So we learned about radians. We reminded ourselves about degrees. Now we need to think back to geometry. Okay. You had two types of special triangles. Do we remember what they were?
3, 4, 5.
Those were your sides. What were the angles?
45, 45.
Cube. 45, 45, 90. And what was the other one?
30, 60,
30, 60, 90. So those are special because they come up a lot. Just like your 3, 4, 5 triangle. That's where we get those from. Those relationships occur a lot.
I just learned about the 3, 4, 5 triangle yesterday.
Well, there you go. So that also means that those are our special angles and degrees. We also want to know what those special angles are in radians as well. So remind me, what is a full rotation in radians? 2 pi. What's a half a rotation in radians? Pi. And then a right angle? Pi over 2. So then what does that mean that a 45-degree angle would have to be?
Pi over 4.
Pi over 4. Because it's going to be half of a half. So then this first one is going to be equivalent to a 30-degree angle. And the third one is our 60-degree angle. Okay? So what is our first one going to be equivalent to? Pi over 6. So notice that we have 6 little pieces, correct, of my first half. And the first, or the top half, we said is pi. So if I'm only looking at one piece of that, I'm looking at 1/6 of the pi. Are y'all with me? Or remember, we also learned our conversion rate. So we could have also taken 30 degrees and multiplied by pi over 180. 30 goes into 180 6 times. Yes. So then our 60-degree angle is going to be what? Pi over 3. Now, what types of angles are 30, 45, and 60 degrees? They're what? Acute, which means that they are what?
Less than 90.
Less than 90. So what quadrant are they in?
The first.
The first. Now, most of the time, we aren't necessarily just going to be dealing with acute angles. So we need to know what our other angles are around our circle. So, in our first quadrant, our placement we just talked about, notice it's going to be $30, 45, and 60. And in our other 3 quadrants, we have angles that are in like similar positions as to those 3 first angles. And so what we want to do is find the rest of them. Because just like our 30, 45, and 60 happen a lot, there are common angles. The ones that are in similar positions in the rest of our circle are also common angles, or things that we see a lot. So we kind of need to figure out what they are. Are y'all with me so far? Yes? Alright. But first off, let's label some of the other things that we should know. So if I haven't moved anywhere, what is my degree measurement? 0. So this first one's going to be 0. Our right angle is going to be 90. Our straight angle, or all the way across, is going to be, going down is going to be 270. And all the way around is 360. Alright, so if I look at my 30-degree angle, and then I'm trying to figure out, again, this is going to be in the same position, okay, as it. So it's the same distance away from here as it is from here. So what angle is in between those two things then? It's a 90-degree angle. So how could I figure out what the angle measurement of this second line is?
Add 90 to 30.
Agreed. So what would we get? 120. So this angle is at 120 degrees. What about for our 45-degree angle? Add 45 to 90, and so what do we get? 135. And then lastly, if we add 60 to 90, what do we get? 150?
What do you get if you add 90 to 90?
You get 180. Because you'd be adding a right angle to another right angle, so we get 180. So now, if I'm looking at the ones that are in my third quadrant, how could I find that one? Add 180. So 30 plus 180 gives us 210. 45 plus 180 gives us 225. And then 60 plus 180 gives us 240. Are we all okay with those? Yes? Questions so far? So then our last quadrant is going to work very similarly. Either we could take our first three and add 270, or we could take our second quadrant and add 180. Either way. So if we do that, what are we going to get? So what do we get for our first one? 300. And then 315. And then 330. So these are our special angles in degrees, and we do need to have these memorized. But do I really have to memorize the entire circle? I need to know the rule to find it, right? So which quadrant do we have to have memorized? The first one. As long as we have that one memorized, I can add 90, 180, and 270 to each of those to figure out what the other quadrants would be. Does that make sense? So this is going to be the basis of what we call our unit circle. And basically our unit circle is our one-stop shop that gives us a lot of information that we need. So these are our common angles, okay? Now, these are all in degrees, but is degrees our only form of measurement that we have learned now? No. What do we also learn? Radians. So we also need to look at these in radians. So if I'm looking at, I have not moved anywhere, what is that? 0. Okay. And then this one was our 30 degree. What did we say that it was? Pi over 6. Our 45 was pi over 4. And our 60 was pi over 3. What's our right angle? Pi over 2. Our straight angle? Pi. Going down, we get 3 pi over 2. And then all the way around is 2 pi. Are we all right with that so far? Yes? No? Maybe? Okay. Now, there are two different ways that we can approach this. The first is that we could just take this circle and use our conversion rate, which remember we would multiply by pi over 180. But we want to practice getting better at doing operations with our radian degree measure. So how did I go from the stuff in my first quadrant to the stuff in my second quadrant for the last one? We added 90. Well, what's the equivalent to 90 in radians? Pi over 2. So, to find my first angle, we're going to take pi over 6 and add pi over 2. So what do we have to do to be able to add fractions? Same denominator. And how do we find that?
Multiplying
Yeah.
whatever.
Okay, so what's our common denominator here?
33.
6. So we would need to multiply by 3 over 3 to my second one. So we get pi over 6 plus 3 pi over 6, which gives us
4 by 6.
4 pi over 6. Can that be reduced? Yes, to 2 pi over 3. Now, on our second one, what do we want to add to pi over 2? To find my second angle. Pi over 4. So what's my common denominator?
2.
4.
What? Yeah.
So I have to multiply by 2.
Same thing.
So what do we get?
3 by over 4. Which cannot be reduced.
Cannot. And then lastly, we're going to add pi over 2 to pi over 3. So what's our common denominator this time? 6. So we get 2 pi over 6 plus 3 pi over 6, which gives us 5 pi over 6. Now, what do we notice about our fractions?
They are.
Is there any type of relationship between? They have the same numbers where? Yeah, so we have the same denominators that we had in our first quadrant. And that's going to be true all the way around. So our denominators for all of our angles are going to be 6, 4, 3, or 2.
Are they going to constantly mirror each other? Like how this one, as it goes from right to left, it goes 6, 4, 3, and then right to left, 3, 4, 6.
Yes.
The same on the bottom, 6, 4, 3, and 3, 4, 6.
Yes.
Oh, sweet.
Okay, also, what do we notice about the relationship between the denominators and the numerators?
They're just one.
They're one less than, so the top is one less than our bottom. Does that make sense? Okay? So, on our third quadrant, what would I do now in order to find these three? I add what? I can add pi to my original 3. So if I take, let's say, pi over 6, to pi, what's our common denominator? 6. So this would become what? 6 pi over 6, so we get 7 pi over 6. If I add it to pi over 4, we get 5 pi over 4. And if I add it to pi over 3,
4
we get 4 pi over 3. So what's the relationship this time between our numerator and denominator? Our numerator is 1 higher. Questions on that? And then on our last quadrant, again, we could either take our first 3 and add 3 pi over 2. Or we could take our second quadrant ones and add pi. So for those, we are going to get should be 5 pi over 3, 7 pi over 4, and 11 pi over 6. So what's the relationship this time between the numerator and the denominator?
One less than double.
Correct. So notice that our first quadrant, it's just going to be that the numerator is equal to 1, right? In our second quadrant, our numerator is, what do we say? The denominator minus 1. Agreed? And in our third quadrant, our numerator
Denominator plus
is our denominator plus 1. And in our fourth,
denominator times 2 minus 1.
agreed. Does that kind of make sense? So again, do we need to memorize the whole circle?
No.
Just the rules. We need to be able to find all the angles for the whole circle, but really we just have to memorize that first quadrant. Once we have that memorized, we can find all the other stuff. And we do have to have this memorized. We have to have this memorized. Okay? Because on this first test, I'm just going to ask you unit circle questions. So like you're just going to fill in parts of the unit circle. But after this first unit, we're basically going to use the unit circle for almost everything that we do. So if you don't have the unit circle memorized, it's going to make your life a whole lot harder. Okay? Because I always have 1 or 2 students that like refuse to memorize it. And by the end of the semester, they're going, why can everybody else do these problems so quickly? And I say, because they have their unit circle memorized. And you don't. Yes. Yes. So, questions, concerns, or comments on that?